Picture this, a vast expanse of space, filled with galaxies swirling in a cosmic dance, yet hiding secrets that defy everything we think we know about the universe. This is the Leo cluster, a region of space so mysterious that even the brightest minds in astronomy are left scratching their heads. What if I told you that within this cluster, there are 25 phenomena that challenge our understanding of reality itself? From stars that vanish without a trace to invisible barriers blocking cosmic rays, the Leo cluster is a treasure trove of cosmic enigmas. But why is this cluster such a hotspot for mysteries? Nestled millions of light years away, it's a dense gathering of galaxies, each one a potential key to unlocking the universe's deepest secrets. Yet, the more we study it, the more questions arise. What could be causing these bizarre events? Are we on the brink of discovering something revolutionary, or are these phenomena simply beyond our comprehension? Stick around, because by the end of this video, you'll not only uncover these 25 unexplained mysteries, but also see the universe in a way you never have before. Ready to dive into the unknown? Let's begin. Now, let's turn our attention to the first of these cosmic puzzles, the missing dark matter. Dark matter is one of the most fundamental components of the universe, making up about 85% of all matter. It's the invisible glue that holds galaxies together, shaping the cosmos as we know it. But here's the twist: some galaxies in the Leo cluster seem to defy this rule entirely. Astronomers have observed galaxies that appear to have little to no dark matter at all. This is baffling because without dark matter, these galaxies shouldn't exist in their current form. They should be flying apart, unable to maintain their structure. So, what's going on? One theory suggests that dark matter might have been stripped away by gravitational interactions with other galaxies in the cluster. Another possibility is that these galaxies formed in a way that's completely different from what we've seen before. Either way, this anomaly challenges our understanding of how galaxies form and evolve. If dark matter isn't as universal as we thought, what does that mean for the rest of the universe? Could there be regions where dark matter behaves differently or even vanishes entirely? This mystery doesn't just shake up our knowledge of the Leo cluster, it forces us to rethink the very fabric of the cosmos. And as we'll see, this is just the beginning of the strange and unexplained phenomena waiting to be uncovered. Now, shifting our gaze to another enigma, we encounter the ghostly radio signals emanating from the Leo cluster. These signals, detected by powerful radio telescopes, seem to come from nowhere and everywhere at once. Unlike the predictable radio waves we observe from pulsars or quasars, these signals are erratic, appearing and disappearing without warning. Astronomers have been left scratching their heads as these transmissions don't match any known cosmic phenomena. One leading theory suggests that these signals could be the result of interactions between massive objects, like colliding galaxies or supermassive black holes. Another intriguing possibility is that they might be remnants of ancient cosmic events, echoes from a time when the universe was far younger and more chaotic. Some even speculate that these signals could be evidence of advanced extraterrestrial civilizations attempting to communicate across the vastness of space. While this idea is highly speculative, it's a reminder of how much we still have to learn about the cosmos. What makes these signals particularly baffling is their unpredictability. They don't follow any discernible pattern, making it nearly impossible to study them in detail. Could they be a natural phenomenon we've yet to understand, or are they hinting at something far more extraordinary? As we continue to explore the Leo cluster, these ghostly radio signals serve as a haunting reminder that the universe is full of mysteries waiting to be unraveled. And with each discovery, we're reminded just how much we still have to learn. Now, as we turn our attention to another cosmic puzzle, we encounter the strange case of the disappearing stars in the Leo cluster. Imagine looking up at the night sky only to watch a star suddenly vanish without a trace. This isn't science fiction. It's a real phenomenon that has left astronomers both fascinated and perplexed. In the Leo cluster, stars have been observed blinking out of existence, leaving no visible remnants like supernova explosions or black hole formations. So, what could be causing these stars to disappear so abruptly? One compelling explanation points to the presence of rogue black holes. These are black holes that drift through space untethered to any galaxy. If a star were to cross paths with one of these invisible giants, it could be swallowed whole, leaving behind no trace of its former existence. Another possibility involves the mysterious nature of dark matter. Some theories suggest that dark matter could interact with stars in ways we don't yet understand, potentially causing them to collapse or disintegrate entirely. But let's not overlook the more speculative angle. Could these vanishing stars be the work of advanced alien civilizations? Some scientists have proposed that highly advanced beings might harness the energy of stars effectively, turning them off as part of their technological endeavors. While this idea remains firmly in the realm of speculation, it's a tantalizing thought that underscores just how much we still have to uncover about the universe. What makes this phenomenon even more intriguing is its unpredictability. Unlike other cosmic events that follow observable patterns, these disappearing stars seem to defy all expectations. They challenge our understanding of stellar life cycles and force us to reconsider what we thought we knew about the cosmos. As we continue to study the Leo cluster, these vanishing stars remind us that the universe is full of surprises, and every mystery we solve only leads to more questions. What else might be hiding in the depths of space, waiting to be discovered? Shifting our gaze to another enigma in the Leo cluster, we encounter the baffling phenomenon of gamma-ray bursts. These are not your ordinary cosmic fireworks. Gamma-ray bursts are the most energetic explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. Yet, despite their staggering power, their origins remain shrouded in mystery. In the Leo cluster, astronomers have detected gamma-ray bursts that defy conventional explanations. Typically, these bursts are linked to cataclysmic events like the collapse of massive stars or the collision of neutron stars. However, the bursts observed in the Leo cluster don't align with these known triggers. They appear to originate from regions of space where no such violent events are occurring, leaving scientists scratching their heads. One theory suggests that these bursts could be the result of interactions between dark matter and ordinary matter. Dark matter, which makes up a significant portion of the universe, remains one of the greatest unsolved puzzles in astrophysics. If it were to interact with visible matter in unexpected ways, it could potentially produce the immense energy observed in these gamma-ray bursts. Another possibility involves the presence of exotic objects such as quark stars or primordial black holes, whose behavior we have yet to fully understand. What makes these gamma-ray bursts particularly intriguing is their potential to reshape our understanding of cosmic events. If their origins are tied to unknown processes or objects, they could unlock new chapters in astrophysics, revealing phenomena we've never even imagined. They challenge our current models of the universe and push us to rethink the fundamental forces at play in the cosmos. As we continue to study these bursts, one thing is clear: the Leo cluster is a treasure trove of cosmic mysteries. Each discovery, like these gamma-ray bursts, not only deepens our understanding but also reminds us of how much we have yet to learn. What other secrets might this cluster hold, waiting to be uncovered? Now, let's turn our attention to another head-scratching mystery in the Leo cluster: the unusual rotation of galaxies. Normally, galaxies rotate in a way that aligns with our understanding of gravity and motion. Stars on the outer edges move slower than those closer to the center, following predictable patterns. But in the Leo cluster, some galaxies are spinning in ways that completely defy these expectations. These galaxies rotate at speeds that shouldn't be possible under our current physics models. Stars on the outer edges are moving far faster than they should, almost as if some invisible force is giving them an extra push. This anomaly has left astronomers puzzled, as it challenges the very foundation of how we think galaxies behave. One possible explanation involves dark matter. While dark matter is invisible, its gravitational effects are undeniable. Some scientists suggest that an uneven distribution of dark matter within these galaxies could be causing the unusual rotation. However, this theory doesn't fully account for the extreme speeds observed, leaving room for other possibilities. Another idea points to the influence of the Leo cluster's environment. The cluster is densely packed with galaxies, and their gravitational interactions could be warping the rotation of individual galaxies in unexpected ways. Yet, even this explanation falls short of fully explaining the phenomenon, as the observed rotations are far more extreme than what typical gravitational interactions would produce. What makes this mystery so significant is its potential to rewrite the rules of astrophysics. If these galaxies are spinning in ways that our current models can't explain, it could mean there's a fundamental gap in our understanding of gravity, motion, or even the nature of dark matter. It's a reminder that the universe often operates in ways that defy our expectations, pushing us to rethink what we thought we knew. As we continue to study these oddly rotating galaxies, one thing is certain: the Leo cluster is a place where the rules of physics seem to bend, if not break entirely. What other surprises might this cosmic neighborhood hold, and how will they reshape our understanding of the universe? Now, let's shift our focus to something even more baffling: an invisible barrier in the Leo cluster that seems to defy the very laws of physics. Imagine a cosmic wall, unseen yet powerful enough to block certain types of cosmic rays from passing through. This isn't science fiction, it's a real phenomenon that has left scientists scratching their heads. Cosmic rays are high-energy particles that travel through space at incredible speeds, often originating from supernova or other violent cosmic events. Normally, these particles zip through galaxies and clusters unimpeded. But in the Leo cluster, something strange is happening. Observations suggest that certain cosmic rays are being stopped in their tracks, as if they've hit an invisible force field. So, what could be causing this mysterious barrier? One leading theory points to magnetic fields. The Leo cluster is known to have incredibly strong magnetic fields, which could potentially deflect or trap cosmic rays. However, the scale and strength of this barrier are far beyond what typical magnetic fields could produce, leaving scientists to wonder if there's something more at play. Another possibility involves dark matter. While dark matter doesn't interact with light, it does exert gravitational forces. Some researchers speculate that a dense concentration of dark matter in the Leo cluster could be creating a kind of gravitational shield, blocking cosmic rays from passing through. Yet, this idea is still speculative, as dark matter's exact nature remains one of the biggest mysteries in astrophysics. The implications of this invisible barrier are profound. If it's real, it could challenge our understanding of how cosmic rays travel through the universe and how structures like galaxy clusters influence their movement. It might also hint at new, unknown forces or interactions at work in the cosmos, waiting to be discovered. As we continue to study this phenomenon, one thing is clear: the Leo cluster is a place where the universe seems to play by its own rules. What other secrets might this invisible barrier hold, and how will they reshape our understanding of the cosmos? The answers could be as groundbreaking as the mystery itself. Now, let's turn our attention to another enigma lurking in the depths of the Leo cluster: phantom gravity waves. These mysterious ripples in the fabric of space-time have been detected, but their origins remain shrouded in uncertainty. Unlike the gravitational waves we've come to understand, those produced by cataclysmic events like colliding black holes or neutron stars, these phantom gravity waves don't seem to align with any known cosmic phenomena. Gravity waves or gravitational waves are disturbances in spacetime caused by massive objects accelerating or colliding. They were first predicted by Albert Einstein over a century ago and were finally observed directly in 2015. But the waves detected in the Leo cluster are different. They don't match the patterns we'd expect from typical sources. Instead, they appear to be faint, erratic, and seemingly disconnected from any visible cosmic events. So, what could be generating these phantom gravity waves? One possibility is that they're coming from objects or processes we've yet to discover. For instance, there could be exotic objects in the Leo cluster, like primordial black holes or strange forms of matter, that produce these waves in ways we don't yet understand. Another theory suggests that these waves might be the result of interactions between dark matter and ordinary matter, creating ripples in spacetime that we're only now beginning to detect. The implications of these phantom gravity waves are profound. If they're real, they could challenge our current understanding of spacetime itself. Einstein's theory of general relativity has been remarkably successful in explaining gravity, but these waves might hint at gaps in our knowledge or even point to new physics beyond Einstein's framework. Could they be evidence of extra dimensions, as some theories suggest, or do they reveal a deeper connection between gravity and the quantum world? As scientists continue to study these elusive waves, one thing is certain: the Leo cluster is a treasure trove of cosmic mysteries. Each discovery, from the invisible barrier to these phantom gravity waves, pushes the boundaries of our understanding and reminds us just how much we have yet to learn about the universe. What other secrets might this cluster hold, and how will they reshape our view of reality? The answers could be as mind-bending as the questions themselves. Now, shifting our gaze to yet another cosmic puzzle, we encounter a phenomenon that defies even the most established theories: glowing dark matter in the Leo cluster. Dark matter, as we know it, is invisible. It doesn't emit, absorb, or reflect light, making it detectable only through its gravitational effects on visible matter. But recent observations in the Leo cluster have revealed something extraordinary: dark matter that appears to glow. This discovery has left scientists scratching their heads. If dark matter doesn't interact with light, how can it emit any form of glow? One possibility is that what we're seeing isn't the dark matter itself, but something entirely new, a form of matter or energy that interacts with dark matter in ways we've never seen before. For instance, there could be particles within the dark matter that, under certain conditions, emit faint light or other forms of radiation. Another theory suggests that the glow might be the result of interactions between dark matter and ordinary matter. In the dense environment of the Leo cluster, where galaxies and gas clouds collide, these interactions could produce energy in the form of light. This would mean that dark matter isn't as dark as we once thought, and that it might have properties we're only beginning to uncover. The implications of glowing dark matter are staggering. If confirmed, it could revolutionize our understanding of the universe's most elusive substance. Dark matter makes up about 85% of the universe's mass, yet we know almost nothing about its true nature. This glow could be the key to unlocking its secrets, revealing how it behaves, how it interacts with other forms of matter, and perhaps even what it's made of. Could this glowing phenomenon hint at a deeper connection between dark matter and the forces that shape the cosmos? Or does it suggest entirely new physics that we've yet to imagine? As researchers continue to study this mysterious glow, one thing is clear: the Leo cluster is a place where the rules of the universe seem to bend, offering us glimpses into the unknown. What other surprises might this cosmic laboratory hold, and how will they reshape our understanding of the cosmos? The answers could be as illuminating as the glow itself. Now, let's turn our attention to a phenomenon that feels almost like a cosmic contradiction: a vast emptiness in the Leo cluster known as the cosmic void. Imagine a region of space so empty that it defies our expectations of what the universe should look like. While the Leo cluster is teeming with galaxies, gas, and dark matter, this void stands out as a stark anomaly, a place where almost no matter exists at all. The existence of such a void raises fascinating questions. How could a region so devoid of matter form in the first place? One leading theory suggests that these voids are the result of the universe's large-scale structure. In the early universe, tiny fluctuations in density led to the formation of dense regions, which eventually became galaxies and clusters, while the less dense regions expanded into voids. Over billions of years, gravity pulled matter into the denser areas, leaving behind these vast, empty spaces. But the cosmic void in the Leo cluster isn't just an absence of matter, it's a window into the universe's architecture. Voids like this one play a crucial role in shaping the cosmic web, the intricate network of filaments and clusters that make up the universe. They act as the negative space that defines the boundaries of galaxies and clusters, helping us understand how matter is distributed on the largest scales. What makes this void particularly intriguing is its sheer size. Stretching across millions of light years, it challenges our understanding of how matter organizes itself in the cosmos. Some scientists speculate that voids like this could be home to exotic forms of energy or even remnants of the early universe that we've yet to detect. Others suggest that the void's emptiness might influence the motion of nearby galaxies, subtly altering their paths in ways we're only beginning to comprehend. The cosmic void also raises questions about the nature of dark energy, the mysterious force driving the universe's accelerated expansion. Could voids like this one be regions where dark energy's effects are more pronounced, or do they hold clues about the universe's ultimate fate? As we study this vast emptiness, we're reminded that sometimes what's missing can be just as revealing as what's present. What does this void tell us about the universe's structure? It's a reminder that the cosmos is full of surprises, from the densest clusters to the emptiest voids. Each discovery pushes us closer to understanding the grand tapestry of existence, and the Leo cluster, with its mysteries and marvels, continues to be one of the most fascinating places to explore. What other secrets might this cosmic void hold, and how will they reshape our understanding of the universe? The answers lie in the emptiness waiting to be uncovered. Now, let's shift our focus to a phenomenon that bends the very fabric of time itself, the time dilation anomaly in the Leo cluster. Time dilation, a concept rooted in Einstein's theory of relativity, suggests that time can stretch or compress depending on gravity and velocity. But in the Leo cluster, something strange is happening. Time dilation effects are being observed that don't quite match what Einstein predicted. This anomaly is not just a curiosity, it's a challenge to our fundamental understanding of time and space. In regions of intense gravity, like near black holes or massive galaxies, time is expected to slow down. This has been observed and confirmed in other parts of the universe. However, in the Leo cluster, astronomers have detected time dilation effects that are either too strong or too weak compared to what current models suggest. For example, light from certain galaxies appears to have traveled through regions where time seems to have passed at an irregular rate, defying the expected gravitational influence of nearby objects. What could be causing this discrepancy? One possibility is the presence of unknown forms of matter or energy that interact with space-time in ways we don't yet understand. Dark matter and dark energy, which already play a mysterious role in the universe, might be influencing time in unexpected ways. Alternatively, the Leo cluster's unique structure, its dense galaxies and vast voids, could create localized distortions in spacetime that amplify or dampen time dilation effects. This anomaly also raises questions about the nature of time itself. Is time truly a constant, as we've long believed, or could it vary in ways we've yet to comprehend? If time dilation in the Leo cluster doesn't align with Einstein's theories, it could mean that our understanding of relativity is incomplete. Perhaps there are deeper layers to the laws of physics that we've yet to uncover, and the Leo cluster is offering us a glimpse into those hidden truths. The implications of this discovery are profound. If time can behave differently in certain regions of the universe, it could reshape our understanding of everything from the Big Bang to the ultimate fate of the cosmos. It might even influence how we think about time travel or the possibility of parallel universes. The Leo cluster, with its time-bending mysteries, is once again pushing the boundaries of what we know or think we know about the universe. As we continue to study this anomaly, one thing is clear. The Leo cluster is a place where the rules of physics seem to bend, twist, and sometimes break. What other secrets about time and space might this cosmic enigma hold? The answers could redefine our understanding of reality itself. Now, let's turn our attention to a theory that sparks both scientific curiosity and imaginative wonder: the alien megastructure hypothesis in the Leo cluster. This idea stems from observations of unusual light patterns emanating from certain galaxies within the cluster. These patterns, which don't align with natural astrophysical phenomena, have led some researchers to propose a startling possibility. Could these be signs of advanced alien civilizations constructing massive structures in space? The concept of alien megastructures isn't new. It was popularized by the idea of Dyson spheres, hypothetical constructs that an advanced civilization might build around a star to harness its energy. In the Leo cluster, astronomers have detected irregular dips in starlight from specific galaxies, dips that can't be easily explained by known celestial objects like planets or dust clouds. Instead, these fluctuations suggest the presence of something large, artificial, and possibly designed by intelligent beings. From a scientific perspective, the search for such megastructures is part of the broader field of astrobiology, which explores the potential for life beyond Earth. While the idea of alien megastructures is speculative, it's grounded in the search for technosignatures, evidence of technology that could indicate the presence of intelligent life. The Leo cluster, with its dense concentration of galaxies, offers a tantalizing environment for such discoveries. If even one civilization in the cluster had reached a level of technological advancement capable of building megastructures, the implications would be staggering. However, it's important to approach this hypothesis with caution. Alternative explanations for the unusual light patterns include natural phenomena like swarms of comets, interstellar debris, or even unknown astrophysical processes. Scientists are actively investigating these possibilities, using advanced telescopes and data analysis to rule out more mundane causes before jumping to extraordinary conclusions. The speculative aspect of this theory is what captures the imagination. If alien megastructures do exist in the Leo cluster, they would represent a monumental leap in our understanding of the universe and our place within it. It would mean that we are not alone and that other civilizations have achieved feats of engineering far beyond our current capabilities. This idea also raises profound questions about the nature of intelligence, technology, and the potential for communication or even collaboration across the cosmos. As we continue to explore the Leo cluster, the search for alien megastructures remains a fascinating blend of science and speculation. Whether these unusual light patterns are evidence of advanced civilizations or simply another cosmic mystery waiting to be solved, they remind us of the boundless possibilities that lie within the universe. What other secrets might the Leo cluster hold? The answers could change everything we think we know about life, intelligence, and the stars themselves. Now, shifting our gaze to another cosmic enigma, we encounter the unsettling behavior of black holes within the Leo cluster. These aren't your typical black holes, stable, predictable, and governed by the laws of physics as we understand them. Instead, the black holes in this region are acting in ways that defy expectations, exhibiting erratic and unpredictable behavior that has left scientists scratching their heads. Black holes are known for their immense gravitational pull, so strong that not even light can escape, Typically, they follow a set of well-documented behaviors, such as consuming nearby matter, emitting radiation, or merging with other black holes. However, in the Leo cluster, some black holes are behaving in ways that challenge these norms. For instance, instead of steadily consuming matter, they appear to flicker, alternating between periods of intense activity and sudden quiet. This irregularity is highly unusual and raises questions about what could be causing such instability. One possible explanation is the presence of an unusually dense environment within the Leo cluster. The cluster is packed with galaxies, gas, and dark matter, creating a chaotic gravitational landscape. This could disrupt the normal feeding patterns of black holes, causing them to behave erratically. Another theory suggests that these black holes might be interacting with exotic forms of matter or energy that we have yet to discover. Such interactions could destabilize their behavior, leading to the strange patterns we observe. The implications of these unstable black holes are profound. If black holes can behave in ways that don't align with our current models, it could mean that our understanding of black hole physics is incomplete. It might also hint at the existence of new physical phenomena or forces at play in the universe. For example, could these black holes be influenced by dark energy, or are they interacting with dimensions beyond our perception? The answers could reshape our understanding of gravity, space-time, and the very fabric of the cosmos. What makes this phenomenon even more intriguing is its potential to reveal new insights into the nature of black holes themselves. By studying these unstable black holes, scientists might uncover clues about how black holes form, evolve, and interact with their surroundings. It could also provide a window into the extreme conditions that exist within the Leo cluster, offering a glimpse of the universe's most violent and mysterious processes. As we continue to observe and analyze these erratic black holes, one thing is clear: the Leo cluster is a treasure trove of cosmic mysteries. Whether these black holes are influenced by unseen forces, exotic matter, or something entirely beyond our current knowledge, they remind us that the universe is far more complex and unpredictable than we often assume. What other secrets might these unstable black holes hold? The answers could unlock new chapters in our quest to understand the cosmos. Now, let's turn our attention to a phenomenon that seems to defy the very nature of space itself: the mysterious cosmic echoes detected in the Leo cluster. These echoes, both in light and sound, have baffled astronomers for years. Unlike the predictable signals we often observe in space, these echoes appear to linger, repeating in patterns that don't align with any known cosmic processes. It's as if the Leo cluster is whispering secrets to us, but in a language we're still struggling to decode. The echoes of light, often referred to as light echoes, occur when light from a sudden burst or explosion bounces off surrounding dust and gas, creating a delayed reflection. While light echoes are not entirely uncommon in the universe, the ones in the Leo cluster are unusual in their intensity and duration. They persist far longer than expected, suggesting that the initial burst of light was either extraordinarily powerful or that the environment in the Leo cluster is amplifying these echoes in ways we don't yet understand. Similarly, the sound echoes detected as faint ripples in the fabric of space-time are equally perplexing. These ripples, often linked to gravitational waves, seem to reverberate through the cluster long after the initial event that caused them. Normally, gravitational waves dissipate quickly, but in the Leo cluster, they linger, creating a kind of cosmic hum that scientists can't fully explain. This raises questions about what could be generating such persistent echoes and why they behave so differently here compared to other regions of space. One theory suggests that the dense environment of the Leo cluster, packed with galaxies, gas, and dark matter, might be acting as a kind of cosmic amplifier. The sheer amount of material in the cluster could be reflecting and prolonging these echoes, creating the unusual patterns we observe. Another possibility is that the echoes are being produced by an entirely new type of cosmic event, one that we haven't yet identified or understood. Could these echoes be the result of collisions between exotic objects, or perhaps the remnants of a long-forgotten supernova that left behind a unique signature? The implications of these cosmic echoes are significant. If they are indeed caused by unknown processes or objects, they could open up entirely new avenues of research in astrophysics. They might also provide clues about the structure and composition of the Leo cluster itself, helping us understand why this region of space behaves so differently from others. For instance, could these echoes be linked to the cluster's mysterious dark matter distribution, or are they hinting at the presence of hidden forces that we have yet to detect? As we continue to study these echoes, one thing is certain: they remind us that the universe is full of surprises. The Leo cluster, with its strange and unexplained phenomena, continues to challenge our understanding of the cosmos. What other secrets might these echoes hold? The answers could reshape our knowledge of space, time, and the very nature of reality itself. And as we listen to these cosmic whispers, we can't help but wonder what else is out there waiting to be discovered. Now, shifting our gaze to another enigma in the Leo cluster, we encounter the baffling case of the phantom galaxies. These are galaxies that seem to appear and vanish over time, as if playing a cosmic game of hide and seek. Unlike the steady, predictable behavior of most galaxies, these phantom galaxies defy our expectations, leaving astronomers both intrigued and puzzled. The phenomenon begins with observations of galaxies that suddenly appear in telescopic images, only to disappear in subsequent observations. At first, scientists thought these might be errors in data collection or processing glitches. But repeated studies confirm that these galaxies are real, and their transient nature is anything but a mistake. So, what could cause a galaxy to seemingly blink in and out of existence? One leading theory points to gravitational lensing, a phenomenon where massive objects like galaxy clusters bend and magnify light from more distant objects behind them. In the dense environment of the Leo cluster, it's possible that the alignment of foreground and background galaxies creates temporary magnifications, making faint galaxies appear suddenly visible. When the alignment shifts, these galaxies might fade back into obscurity, giving the illusion of disappearance. However, this doesn't fully explain why some galaxies vanish entirely, leaving no trace behind. Another possibility involves the mysterious nature of dark matter. If certain regions of the Leo cluster contain dense pockets of dark matter, they could temporarily trap or obscure light from galaxies, making them appear and disappear. Alternatively, these phantom galaxies might be the remnants of ancient cosmic collisions, where galaxies merge and fragment in ways that make them intermittently detectable. The implications of phantom galaxies are profound. If they are indeed a result of gravitational lensing or dark matter interactions, they could provide new insights into the distribution of matter in the universe. On the other hand, if their behavior is caused by something entirely unknown, it could challenge our fundamental understanding of how galaxies form and evolve. Are these phantom galaxies a rare cosmic anomaly, or are they hinting at processes we've yet to uncover? As we continue to study these elusive galaxies, one thing is clear: they remind us that the universe is far more dynamic and unpredictable than we often assume. The Leo cluster, with its phantom galaxies, continues to push the boundaries of our knowledge, inviting us to question what we think we know about the cosmos. What other mysteries might these fleeting galaxies reveal? The answers could reshape our understanding of the universe in ways we can't yet imagine. Now, let's turn our attention to another astonishing mystery in the Leo cluster: the unseen energy source. Deep within this cosmic neighborhood, astronomers have detected galaxies that are being powered by an invisible force, one that defies all conventional explanations. These galaxies shine brightly, yet there's no visible source of energy to account for their luminosity. It's as if the universe is hiding a cosmic battery, and we're only just beginning to uncover its secrets. The first clue to this mystery came when scientists observed galaxies emitting far more energy than their stars alone could produce. Normally, the light and heat from stars are enough to explain a galaxy's energy output. But in these cases, something else, something unseen, is at work. This invisible energy source doesn't just power the galaxies. It seems to sustain them over vast periods of time, raising questions about what could possibly generate such immense and consistent energy. One theory suggests the presence of exotic particles, ones that don't interact with light or ordinary matter but still exert a powerful influence. These particles, often referred to as dark energy candidates, could be releasing energy in ways we don't yet understand. If true, this would not only explain the unseen energy source, but also provide a crucial piece of the puzzle in our search for dark energy, the mysterious force driving the universe's expansion. Another possibility involves unknown cosmic processes, perhaps even phenomena we haven't yet imagined. For instance, some researchers speculate that the energy could be coming from the collision of cosmic strings, hypothetical, one-dimensional defects in space-time. These collisions could release bursts of energy capable of powering entire galaxies. While this idea is still speculative, it highlights just how much we have yet to learn about the universe's inner workings. There's also the intriguing idea that black holes might play a role. Supermassive black holes, often found at the centers of galaxies, are known to emit tremendous energy as they consume matter. But in these cases, the energy output doesn't match the expected behavior of black holes. Could there be a new type of black hole, or perhaps a different mechanism at play that we're only now beginning to detect? The implications of this unseen energy source are staggering. If it's tied to exotic particles or unknown cosmic processes, it could revolutionize our understanding of physics and the universe itself. It might even provide clues about the nature of dark energy and dark matter, two of the greatest mysteries in modern science. On the other hand, if this energy source is something entirely new, it could open up entirely new fields of study, challenging us to rethink the very fabric of reality. As we continue to explore the Leo cluster, this unseen energy source stands as a testament to the universe's endless capacity to surprise us. It reminds us that, even with all our advancements, there are still forces at work that we can't yet see or fully comprehend. What other hidden wonders might the Leo cluster hold? The answers could change everything we know about the cosmos. Now, shifting our gaze to another layer of the Leo cluster's mysteries, we encounter a phenomenon that bends the very fabric of reality: warped space-time. In certain regions of this cosmic expanse, space-time doesn't behave as Einstein's theory of general relativity predicts. Instead, it twists and distorts in ways that leave scientists scratching their heads, challenging our fundamental understanding of gravity and the universe itself. The first hints of this anomaly came from observations of light traveling through the Leo cluster. Normally, light follows a predictable path, bending slightly around massive objects due to gravity, a phenomenon known as gravitational lensing. But in these regions, the bending is far more extreme than expected, as if space-time itself is being stretched and contorted by an unseen force. This suggests that something massive, or perhaps something entirely new, is at work, warping the very structure of the cosmos. One possible explanation involves the presence of dark matter in concentrations far greater than we've ever observed. Dark matter, which doesn't emit light but exerts gravitational pull, could be clumping together in ways that create these intense distortions. If true, this would mean that dark matter isn't just a passive player in the universe. It could actively reshape space-time in ways we're only beginning to understand. Another theory points to the possibility of exotic objects such as primordial black holes or cosmic strings lurking within the Leo cluster. Primordial black holes, thought to have formed in the early universe, could be far more numerous and massive than we've realized, creating localized warps in space-time. Cosmic strings, hypothetical one-dimensional defects in the fabric of the universe, could also be responsible, slicing through space-time and leaving behind ripples of distortion. But perhaps the most intriguing idea is that these warped regions are evidence of a deeper flaw in our understanding of gravity. Einstein's theory has been the cornerstone of modern physics for over a century, but what if it's incomplete? Some scientists speculate that these distortions could be a sign of new physics, a hint that gravity behaves differently on cosmic scales than we've assumed. This could open the door to entirely new theories, reshaping not just our understanding of the Leo cluster but the entire universe. The implications of warped space-time are profound. If dark matter or exotic objects are the cause, it could provide crucial insights into the nature of these elusive entities. If it's a sign of new physics, it could revolutionize our understanding of gravity, space, and time. Either way, these distortions remind us that the universe is far stranger and more complex than we've ever imagined. As we continue to probe the Leo cluster, the mystery of warped space-time stands as a testament to the universe's ability to defy our expectations. It challenges us to think beyond the known, to question the very foundations of our knowledge. What other secrets might these cosmic distortions hold? The answers could rewrite the rules of the cosmos as we know them. Now, let's turn our attention to a phenomenon that seems to play tricks on our cosmic senses: the mysterious shadows cast by unseen objects in the Leo cluster. These shadows, detected by astronomers, appear as dark patches against the backdrop of glowing galaxies and nebulae, yet their origins remain shrouded in mystery. What could be casting these cosmic shadows, and what do they tell us about the hidden structures lurking in this enigmatic region of space? The first clue lies in the nature of shadows themselves. On Earth, shadows are created when an object blocks light from a source like the sun. In space, the principle is similar, but the scale is unimaginably larger. These cosmic shadows suggest the presence of massive objects so dense or vast that they block the light from distant stars, galaxies, or even the faint glow of the cosmic microwave background. But here's the twist: the objects casting these shadows are invisible to our telescopes. They don't emit light, reflect it, or interact with it in any way we can detect. So what are they? One leading theory points to dark matter. As we've discussed earlier, dark matter doesn't interact with light, making it invisible to traditional observation methods. However, its gravitational influence is undeniable. If dark matter clumps together in dense enough formations, it could theoretically block light from passing through, creating these eerie shadows. This would mean that dark matter isn't just a diffuse, invisible presence. It could form structures massive enough to cast shadows across the cosmos. Another possibility involves black holes, particularly supermassive ones. Black holes are known for their ability to trap light, but they also distort the space around them, bending light in ways that can create shadow-like effects. If a supermassive black hole were positioned just right between us and a distant light source, it could cast a shadow that appears as a dark void in the Leo cluster. Yet, no such black hole has been identified in these regions, leaving astronomers puzzled. There's also the intriguing idea of cosmic dust clouds. While dust clouds are typically visible as they scatter or absorb light, some could be so dense and cold that they remain undetected, acting like cosmic curtains that block light from behind them. These clouds, composed of fine particles and gas, might be remnants of ancient star formation or the aftermath of galactic collisions, creating shadows that linger for millions of years. But perhaps the most fascinating explanation lies in the realm of the unknown. Could these shadows be evidence of entirely new cosmic phenomena? Some scientists speculate that they might be caused by exotic objects or structures we've yet to discover, objects that don't fit into our current understanding of physics. For instance, hypothetical constructs like cosmic strings or even advanced alien megastructures could, in theory, cast shadows on such a vast scale. The significance of these cosmic shadows extends far beyond their mysterious origins. If they are indeed caused by dark matter, they could provide a new way to map its distribution in the universe, offering insights into its role in shaping galaxies and clusters. If black holes or dust clouds are the culprits, they could reveal new details about the life cycles of stars and galaxies. And if they point to something entirely unknown, they could open the door to groundbreaking discoveries that redefine our understanding of the cosmos. As we continue to study the Leo cluster, these shadows serve as a reminder of how much we still have to learn. They challenge us to look beyond the visible, to question what we think we know, and to explore the hidden corners of the universe. What other secrets might these shadows hold? The answers could illuminate not just the Leo cluster, but the very nature of reality itself. Now, shifting our gaze to another cosmic enigma, we encounter the unpredictable supernova within the Leo cluster. These stellar explosions, which mark the dramatic end of a star's life, are behaving in ways that defy our current understanding of astrophysics. Normally, supernovae follow predictable patterns based on the mass and composition of the star, but in the Leo cluster, some of these explosions are breaking all the rules. One of the most baffling aspects is the timing of these supernovae. In many cases, stars in the Leo cluster are exploding earlier or later than our models predict. For instance, some massive stars, which should take millions of years to reach the end of their life cycles, are detonating prematurely. Others, which should have exploded long ago, are lingering far beyond their expected lifespans. This inconsistency challenges our understanding of how stars evolve and what triggers their final, cataclysmic moments. Another puzzling feature is the energy output of these supernovae. Some explosions in the Leo cluster are far more energetic than they should be, releasing bursts of light and radiation that dwarf typical supernovae. Others, surprisingly, are much dimmer, almost as if they're fizzling out before reaching their full potential. This variability suggests that there are factors at play in the Leo cluster that we haven't yet accounted for in our stellar models. One possible explanation lies in the unique environment of the Leo cluster itself. The cluster is densely packed with galaxies, stars, and interstellar gas, creating a dynamic and chaotic environment. Interactions between stars, such as collisions or close encounters, could alter their life cycles in unexpected ways. For example, a star might gain or lose mass through these interactions, changing its fate and leading to an unusual supernova. Additionally, the presence of dark matter or other unseen forces in the cluster could be influencing stellar evolution in ways we don't yet understand. Another intriguing possibility is that these supernovae are revealing new types of stellar deaths. Scientists have theorized about exotic mechanisms such as pair instability supernova or the collapse of stars into black holes that could produce the strange behaviors observed in the Leo cluster. These events might involve stars with unusual compositions or conditions that aren't accounted for in our current models, opening the door to entirely new categories of supernova. The implications of these unpredictable supernovae are profound. If they are caused by interactions within the cluster, they could provide new insights into how stars evolve in dense environments, shedding light on the formation and evolution of galaxies. If they point to new types of stellar deaths, they could revolutionize our understanding of stellar physics and the life cycles of stars. Either way, these cosmic explosions are forcing us to rethink what we know about the universe. As we continue to study the Leo cluster, these enigmatic supernovae remind us that the cosmos is full of surprises. They challenge us to refine our models, to question our assumptions, and to explore the unknown. What other secrets might these stellar explosions hold? The answers could illuminate not just the Leo cluster, but the very nature of stars themselves. Now, let's turn our attention to a phenomenon that seems to defy the very fabric of cosmic logic: intergalactic lightning in the Leo cluster. Imagine, if you will, vast arcs of electricity stretching between galaxies, crackling with energy on a scale that dwarfs anything we've ever seen on Earth. These colossal discharges, resembling lightning but on an unimaginably grander scale, are one of the most electrifying mysteries in the cluster. What makes these intergalactic lightning bolts so extraordinary is their sheer size and power. Unlike the lightning we're familiar with, which occurs within a single planet's atmosphere, these discharges span the vast distances between galaxies. They're not just flashes of light, they're immense streams of charged particles carrying energy that could power entire civilizations for millennia. But how does something like this even happen? What could possibly generate such massive electrical phenomena in the cold, seemingly empty void of space? One leading theory points to the turbulent environment of the Leo cluster itself. The cluster is a bustling hub of galaxies, gas, and magnetic fields, all interacting in complex ways. When galaxies collide or pass close to one another, their magnetic fields can become twisted and tangled, creating regions of intense electrical activity. These interactions might generate enormous electric potentials, building up until they discharge in the form of intergalactic lightning. It's a cosmic version of the static electricity you might experience when rubbing a balloon on your hair, but on a scale that's almost impossible to comprehend. Another possibility involves the role of supermassive black holes. Many galaxies in the Leo cluster host these gravitational giants at their centers, which are known to produce powerful jets of particles and radiation. These jets could interact with the surrounding gas and magnetic fields, creating conditions ripe for massive electrical discharges. In this scenario, the black holes act as cosmic power plants, generating the energy needed to produce these spectacular lightning-like phenomena. There's also the intriguing idea that dark matter might play a role. While dark matter doesn't interact with light or electricity in the way normal matter does, its gravitational influence could shape the environment in which these discharges occur. By altering the distribution of gas and magnetic fields, dark matter might indirectly contribute to the creation of intergalactic lightning, adding another layer of mystery to this already puzzling phenomenon. The implications of these electrical discharges are profound. If they're caused by interactions between galaxies, they could provide new insights into how galaxies evolve and influence one another in dense clusters. If black holes are the source, they could reveal new aspects of how these enigmatic objects shape their surroundings. And if dark matter is involved, it could offer clues about its elusive nature and how it interacts with the visible universe. As we continue to study the Leo cluster, these intergalactic lightning bolts remind us that the cosmos is far more dynamic and unpredictable than we often imagine. They challenge us to rethink our understanding of electricity, magnetism, and the forces that shape the universe. What other electrifying secrets might the Leo cluster hold? The answers could spark a revolution in our understanding of the cosmos. Now, shifting our gaze to another mesmerizing enigma in the Leo cluster, we encounter a phenomenon that seems to defy the very laws of cosmic motion, the cosmic whirlpool. Picture a vast, swirling vortex of gas, dust, and galaxies, spinning with such force that it resembles a whirlpool on a cosmic scale. This colossal structure, stretching across millions of light years, is not just a visual spectacle but a profound mystery that challenges our understanding of how the universe operates. What makes this cosmic whirlpool so extraordinary is its sheer size and the forces at play. Unlike the whirlpools we see on Earth, which are driven by water currents, this cosmic version is powered by the interplay of gravity, dark matter, and the immense energy of the cluster itself. The Leo cluster is a dense region packed with galaxies and intergalactic gas, all moving and interacting in ways that create these massive, swirling patterns. But how does such a structure form, and what keeps it spinning with such precision? One leading theory suggests that the cosmic whirlpool is the result of a galactic collision. When two or more galaxies collide, their gravitational forces can create a chaotic yet organized dance, pulling gas and stars into a swirling motion. Over time, this motion can settle into a stable, whirlpool-like structure, with galaxies and gas orbiting a central point. This process is similar to how water spirals down a drain, but on a scale that's almost unimaginable. Another possibility involves the role of dark matter. While dark matter doesn't emit light or interact with electromagnetic forces, its gravitational influence is immense. In the Leo cluster, dark matter could be shaping the distribution of gas and galaxies, creating the conditions necessary for a cosmic whirlpool to form. The invisible hand of dark matter might be guiding the motion of visible matter, orchestrating this grand, swirling dance across the cosmos. There's also the intriguing idea that supermassive black holes could be contributing to this phenomenon. Many galaxies in the Leo cluster host these gravitational giants at their centers, which are known to produce powerful jets of energy. These jets could interact with the surrounding gas, creating turbulence that feeds into the whirlpool's motion. In this scenario, black holes act as cosmic engines, driving the swirling motion and adding to the complexity of the structure. The implications of this cosmic whirlpool are profound. If it's the result of galactic collisions, it could provide new insights into how galaxies interact and evolve in dense clusters. If dark matter is the key player, it could offer clues about its elusive nature and how it shapes the universe on large scales. And if black holes are involved, it could reveal new aspects of how these enigmatic objects influence their surroundings. As we continue to study the Leo cluster, this cosmic whirlpool serves as a reminder of the dynamic and ever-changing nature of the universe. It challenges us to rethink our understanding of gravity, motion, and the forces that shape the cosmos. What other swirling secrets might the Leo cluster hold? The answers could unravel new mysteries and deepen our appreciation for the intricate dance of the universe. Now, as we venture deeper into the mysteries of the Leo cluster, we encounter a phenomenon that radiates intrigue in more ways than one: the phantom radiation. Imagine a faint, ghostly glow of energy permeating the cluster, invisible to the naked eye but detectable through advanced instruments. This radiation doesn't match any known source, leaving scientists puzzled about its origins and what it might reveal about the cosmos. The phantom radiation is particularly baffling because it doesn't align with the typical emissions we associate with stars, galaxies, or even black holes. Instead, it appears as a diffuse, almost ethereal presence spread across vast regions of the cluster. Some theories suggest it could be the remnants of ancient cosmic events, such as the explosive deaths of massive stars or the collision of galaxies. These cataclysmic events could have released energy that lingers, creating this mysterious glow. Another possibility is that the radiation is linked to dark matter. While dark matter itself doesn't emit light, its interactions with ordinary matter or other dark matter particles could produce faint signals. If this is the case, the phantom radiation could be a rare glimpse into the hidden world of dark matter, offering clues about its properties and behavior. This would be a groundbreaking discovery, as dark matter remains one of the most elusive components of the universe. There's also the intriguing idea that the radiation could be coming from an entirely new type of cosmic object or phenomenon. Perhaps it's the signature of exotic particles or energy fields that we haven't yet identified. The Leo cluster, with its dense and dynamic environment, might be the perfect place for such unknown entities to exist, hidden in plain sight yet detectable through their subtle emissions. The implications of this phantom radiation are profound. If it's tied to ancient cosmic events, it could provide a window into the history of the Leo cluster, revealing how it evolved over billions of years. If it's connected to dark matter, it could revolutionize our understanding of this mysterious substance and its role in shaping the universe. And if it's something entirely new, it could open up entirely new avenues of research, challenging our current models of physics. As we continue to study the Leo cluster, the phantom radiation stands as a testament to the universe's endless capacity to surprise us. It reminds us that even in the most well-studied regions of space, there are still secrets waiting to be uncovered. What could this ghostly glow be telling us about the cosmos? The answers might just rewrite the story of the universe as we know it. Now, shifting our gaze to another enigmatic feature of the Leo cluster, we encounter a phenomenon that seems to defy the very nature of reality, the galactic mirage. Picture this: galaxies that appear stretched, warped, or even duplicated, as if viewed through a cosmic funhouse mirror. These distortions, known as gravitational lensing, occur when the immense gravity of massive objects like galaxy clusters bends the light from more distant galaxies behind them. But in the Leo cluster, these mirages are not just ordinary distortions, they're extreme, puzzling, and hint at something far more profound. At the heart of this mystery lies the interplay between light and gravity. When light from a distant galaxy travels through the Leo cluster, it passes through regions of intense gravitational pull. This causes the light to curve, much like a lens bending light in a telescope. The result: galaxies that appear in places they shouldn't, or in shapes that seem impossible. These mirages are not just optical illusions, they're windows into the hidden structure of the universe itself. One possible explanation for these extreme distortions is the presence of an unusually high concentration of dark matter in the Leo cluster. Dark matter, which doesn't emit light but exerts gravitational force, could be amplifying the lensing effect, creating more dramatic and intricate mirages than we've observed elsewhere. If this is the case, these galactic mirages could be indirect evidence of dark matter's distribution and influence, offering clues about its role in shaping the cosmos. Another intriguing possibility is that the distortions are caused by something even more exotic, like a cosmic string or a defect in the fabric of space-time. These theoretical structures, predicted by some models of physics, could create unique gravitational effects, bending light in ways that challenge our current understanding. While cosmic strings remain speculative, their potential discovery through phenomena like these mirages could revolutionize our knowledge of the universe's fundamental structure. The implications of these galactic mirages are far-reaching. By studying them, astronomers can map the distribution of both visible and dark matter in the Leo cluster, piecing together a more complete picture of its composition. They also provide a unique opportunity to test Einstein's theory of general relativity on cosmic scales, probing whether our understanding of gravity holds true in the most extreme environments. But perhaps the most exciting aspect of these mirages is what they reveal about the universe's capacity to surprise us. They remind us that even the most familiar phenomena, like light and gravity, can behave in unexpected ways when viewed through the lens of the cosmos. As we continue to unravel the secrets of the Leo cluster, these galactic mirages stand as a testament to the endless mysteries waiting to be uncovered. What else might these cosmic distortions be hiding? The answers could reshape our understanding of the universe itself. Now, let's turn our attention to a phenomenon that challenges everything we thought we knew about black holes: the silent supermassive black hole in the Leo cluster. Unlike most supermassive black holes, which are known for their voracious appetites and dramatic displays of energy, this one is eerily quiet. It emits no detectable radiation, no jets of particles, and no telltale signs of activity. It's as if this cosmic giant has gone into hibernation, leaving astronomers scratching their heads. Typically, supermassive black holes are surrounded by swirling disks of gas and dust known as accretion disks. As these materials spiral inward, they heat up and emit intense radiation, including X-rays and radio waves. This makes them some of the brightest objects in the universe. But the silent black hole in the Leo cluster defies this norm. Its lack of detectable radiation suggests that it's not actively feeding, or that its accretion disk is somehow absent or inactive. This raises a critical question. Why is this black hole so quiet? One possibility is that the black hole has simply run out of fuel. In the dense environment of a galaxy cluster, black holes are usually surrounded by plenty of gas and stars to consume. But if this black hole has exhausted its nearby resources, it might have entered a dormant phase, waiting for new material to fall into its grasp. Alternatively, the black hole could be feeding in a way that doesn't produce the usual radiation. Some theories suggest that it might be consuming matter so slowly or efficiently that it doesn't generate the intense energy emissions we typically associate with black holes. Another intriguing explanation involves the black hole's environment. The Leo cluster is home to a complex web of gravitational interactions which could be influencing the black hole's behavior. Perhaps the surrounding galaxies and dark matter are redirecting gas and dust away from the black hole, starving it of the material it needs to shine. Or maybe the black hole is ejecting matter in a way that doesn't produce detectable radiation, creating a kind of cosmic stealth mode. The implications of this silent supermassive black hole are profound. If black holes can exist in such a dormant state, it could mean that there are many more of them lurking in the universe than we've previously detected. This would force us to rethink how we search for and study these enigmatic objects. It could also challenge our understanding of black hole evolution, suggesting that they go through periods of activity and inactivity, much like stars or galaxies. Moreover, this phenomenon could provide new insights into the nature of black holes themselves. If a supermassive black hole can exist without emitting radiation, it might hint at unknown mechanisms governing their behavior. Could there be entirely new states or phases of black holes that we've yet to discover? The silent black hole in the Leo cluster invites us to consider these possibilities, pushing the boundaries of our knowledge and opening new avenues for exploration. As we continue to study this mysterious object, one thing is clear: the universe is full of surprises. The silent supermassive black hole reminds us that even the most well-understood cosmic phenomena can defy our expectations, challenging us to look deeper and think differently. What other secrets might this quiet giant be hiding? The answers could reshape our understanding of black holes and the universe itself. Now, let's shift our gaze to another cosmic enigma that has left scientists both fascinated and puzzled: the unexplained ripples in the fabric of space-time within the Leo cluster. These ripples, often referred to as gravitational waves, are not entirely new to us. We've detected them before, originating from cataclysmic events like colliding black holes or neutron stars. But the ripples in the Leo cluster are different. They don't seem to match any known cosmic events, and their origins remain shrouded in mystery. Imagine space-time as a vast, calm lake. When a massive object moves or collides, it creates ripples on the surface, much like a stone thrown into water. These ripples are gravitational waves, and they carry information about the events that caused them. In the Leo cluster, however, the ripples detected don't align with any known sources. They're faint yet persistent, and their patterns don't correspond to the usual suspects like black hole mergers or supernova. So, what could be causing them? One possibility is that these ripples are the result of interactions between dark matter and ordinary matter. Dark matter, which makes up a significant portion of the universe, doesn't emit light or radiation, making it invisible to our telescopes. But its gravitational effects are undeniable. If dark matter clumps or moves in specific ways within the Leo cluster, it could generate these subtle ripples in space-time. This would be a groundbreaking discovery, as it could provide the first direct evidence of dark matter's influence on the cosmic fabric. Another theory points to the presence of exotic objects or phenomena we've yet to discover. For instance, some scientists speculate that these ripples could be caused by cosmic strings, hypothetical, one-dimensional defects in space-time left over from the early universe. If cosmic strings exist, their vibrations could produce gravitational waves with unique signatures, unlike anything we've observed before. Alternatively, the ripples might be the result of multiple smaller events happening simultaneously, creating a complex pattern that's difficult to decipher. The implications of these cosmic ripples are profound. If they are indeed linked to dark matter or exotic phenomena, they could revolutionize our understanding of the universe's composition and evolution. They might also provide new insights into the nature of gravity itself, potentially revealing flaws or extensions to Einstein's theory of general relativity. For instance, if the ripples exhibit properties that don't align with current models, it could hint at new physics operating on cosmic scales. Moreover, studying these ripples could help us map the Leo cluster in unprecedented detail. Gravitational waves carry information about their sources, and by analyzing their patterns, we might uncover hidden structures or dynamics within the cluster. This could shed light on how galaxies and dark matter interact, offering clues about the formation and evolution of galaxy clusters themselves. As we continue to probe these mysterious ripples, one thing is certain: they remind us that the universe is far more complex and dynamic than we often assume. Each new discovery challenges our existing frameworks and pushes us to rethink what we know about the cosmos. What other secrets might these ripples hold? The answers could not only deepen our understanding of the Leo cluster, but also transform our view of the universe as a whole. Now, let's turn our attention to a phenomenon that seems to defy the very nature of the cosmos, a region within the Leo cluster that glows with what appears to be endless light. Unlike the fleeting brilliance of stars or the transient flashes of supernova, this light persists, casting an eternal glow that has left astronomers both awestruck and perplexed. What could possibly sustain such a radiant display in the depths of space? At first glance, one might assume this perpetual light is the result of an incredibly dense cluster of stars. After all, the Leo cluster is home to thousands of galaxies, each brimming with billions of stars. But the sheer intensity and consistency of this glow suggests something far more extraordinary. Stars, even in vast numbers, have lifespans and eventual fates. They burn out, explode, or collapse. Yet this light shows no signs of dimming or fading, raising questions about its true source. One compelling theory points to the possibility of an immense, superheated gas cloud. Such clouds, when energized by nearby galaxies or black holes, can emit vast amounts of light. However, even these clouds would eventually cool or disperse, making it difficult to explain the sustained glow observed in the Leo cluster. Could there be a continuous energy source replenishing this light, or is it something entirely different? Another intriguing idea involves the interaction of dark energy, the mysterious force driving the accelerated expansion of the universe. Some scientists speculate that dark energy might manifest in unexpected ways, such as creating regions of perpetual illumination. If true, this would not only explain the endless light, but also provide a rare glimpse into the behavior of dark energy itself, a discovery that could reshape our understanding of the universe's fundamental forces. Alternatively, the glow might be linked to phenomena we've yet to fully comprehend, such as quantum fluctuations or exotic particles. These could generate energy in ways that defy our current physical models, producing light that appears to have no end. The implications of such a discovery would be staggering, potentially opening the door to entirely new branches of physics. The endless light also raises questions about the nature of time and space within the Leo cluster. Could this region be experiencing a unique distortion of time, where processes that would normally take eons occur in an instant, creating the illusion of perpetual light? Or is it a sign of a cosmic anomaly, a place where the rules of physics as we know them no longer apply? As we ponder these possibilities, one thing is clear: the endless light of the Leo cluster challenges our understanding of the universe in profound ways. It serves as a reminder that, even in the vastness of space, there are phenomena that defy explanation, urging us to look deeper and question further. What other mysteries might this radiant region hold? The answers could illuminate not just the Leo cluster, but the very fabric of reality itself. As we reach the end of our journey through the Leo cluster, it's impossible not to be struck by the sheer magnitude of its mysteries. From the missing dark matter and ghostly radio signals to the endless light and cosmic ripples, each phenomenon challenges our understanding of the universe in profound ways. These 25 unexplained occurrences are not just isolated curiosities, they are pieces of a larger puzzle, hinting at forces and principles we have yet to fully grasp. Together, they remind us that the cosmos is far more complex and enigmatic than we often imagine. The Leo cluster serves as a cosmic laboratory, offering glimpses into phenomena that defy our current scientific frameworks. Whether it's the phantom galaxies that flicker in and out of existence, the unstable black holes that behave unpredictably, or the warped space-time that bends the rules of physics, each mystery pushes the boundaries of what we know. These anomalies are not just challenges to astronomers, they are invitations to explore, to question, and to dream. They remind us that the universe is still full of secrets waiting to be uncovered. So, what do these mysteries mean for us? They are a testament to the boundless curiosity of humanity, driving us to look deeper into the cosmos and seek answers to questions we've only begun to ask. They remind us that science is not just about finding answers, it's about embracing the unknown and finding wonder in the questions themselves. The Leo cluster, with its endless light and cosmic shadows, is a beacon of that wonder, urging us to keep exploring, keep questioning, and keep imagining. What do you think lies at the heart of these cosmic mysteries? Could they be clues to a deeper understanding of the universe, or are they signs of phenomena we've yet to even conceive? Share your thoughts and theories in the comments below. Let's continue this journey of discovery together. And if you enjoyed this exploration of the Leo cluster, don't forget to like, subscribe, and hit the notification bell for more deep dives into the wonders of the cosmos. The universe is vast and its mysteries are endless, so let's keep exploring them, one mystery at a time.